Guys, write down the f function and the g function. Here's your f function, here's your g function. I'm starting out with some simple functions right here to help you guys understand combinations of functions, this section. Okay, so this is what we're going to do. Just a recap, or not a recap, but an overview. We're going to add the functions together. We're going to subtract the functions. We're going to multiply the functions. Then we're going to divide the functions. And then these last ones right here, these are called compositions. We're going to do those as well. But let's blow through these really fast. So I'm going to do something different. I'm going to ask you guys to do these right now without me, without any help whatsoever, and then I will work on them with you. So take 3 minutes to do those right now. Go. So for our h function, we're adding the f and the g. So let's do our h function first. What does our h function look like? It looks like this. But the first thing you got to do is add or combine like terms. I mean, you got to simplify. So the x term, we got to add those two terms together. The 2, it does not have a denominator of 4, so let's make it have a denominator of 4. So instead of 2, it would be, 8 over 4? 8 over 4 minus 3 over 4 would be 5 over 4 x, and then we're going to add our two constants together. We have 1 and 3. We add those together, we get 4. So this is our h function. Question. Changing this into 1 1/4 is fine. It's the same answer, but if I left it like this, I can easily see what my slope is. The rise is 5, the run is 4. Okay, now let's look at j. All right, let's see, j we have to subtract. So I'm going to take the first function. We have 2x plus 1, that's the f. Then we're going to subtract, but I'm going to have parentheses right here to make sure I remind myself that I must distribute that negative. So you see how it says minus g? So there's minus, and then I put the g function right inside there. So I distribute the negative, so this is what I got. So I get, this is 8 over 4, and I'm adding 8 over 4 to 3 over 4, so that's going to be, what is that, to 11 over 4, x, plus, and then we have positive 1 and negative 3, so actually I can write negative 2. So that's my j function. All right. What does my next function look like? That's the k function. All right, now let's do the k function. For the k function, we have to multiply them together. That's going to be a little bit more work to do. So we have 2x plus 1 times negative 3 over 4x. What was it? Plus 3? Plus 3. Alrighty. So that times that, which is going to be 3 over 2, negative 3 over 2x squared. That times that, which is going to be 6x. That times that. We get negative 3 over 4x. And then we have that times that, which is positive 3. So now we have negative 3 over 2x squared. And we're adding the like terms right here. That would be 5 1/4 x plus 3. That's it. So this is our k function. He looks the nasty out of all of them. He is the nasty. Okay, last one of L, and then we're going to do our composition. So for the L, we're going to take the f function, which is 2x plus 1, and we're going to divide it by negative 3 over 4x plus 3. That's it. That's your answer, because you can't divide them. But there is something important to note for L. L, you can't plug in anything you want into L. We have a restriction. You cannot plug something into that x. The number you cannot plug into that x is whatever makes this equal 0. So let's do that really quick. So negative 3 over 4x plus 3 equals 0. I would subtract 3 from both sides. And then to get rid of that fraction, you could either multiply by the reciprocal or break it into 2 steps. You can multiply both sides by 4. So that would go away, and you would have negative 12 over here. Then you have negative 3x. And then you divide both sides by negative 3. You have x equals 4. Now, if I plugged in 4 to this, it would make the denominator 0. And what's so important about that? It can never be 0. We can't have a denominator that equals 0. So that means x can never be 4. And so you say x cannot equal 4. This is known as a restriction or excluded value. I'm going to write excluded value. All right, let me pause right here and ask for questions. Here we go. Now let's do the M, N, and the P. Now these are called compositions. These are new to you most likely. Okay, they're all doing the same exact thing. They're taking a function and plugging it into another function. I think the first one is the most readable. You can tell what you're plugging into what. What am I plugging into the F function? I'm plugging the G function into it. So whatever the G function is, you're plugging it into the F. Oh. So let's write out M. How would this look? M. And I'm gonna try to use two colors here. Let's use this color for the F. All right, so I'm gonna write 2, and I'm putting parentheses for the something that gets plugged into the F, and there you go. So that's F, right? 2x plus 1, that's F. Everybody's cool? No big? Now G, let's do purple for this guy. I'm gonna go -3 over 4x plus 3. All right, that's it. Now you have to simplify. So I plug the G into the F. Now it's simplify time. So I go this guy times this guy. That's going to be -3 over 2x plus 6. Then I have that plus 1 chilling out there. That's going to add to the 6 to get my final answer. What is M? M is -3 over 2x plus 7. This is G plugged into F. Now let's do this one. And this one, N, it's written as a weird way. I wrote it this way. I didn't put the X. I didn't put like N of X and G of X and F of X. But I just wrote out the letters that represent functions. This is how you would translate this. This is the same as G of F of X. So it's almost like I'm putting parentheses like that. I'm putting the F inside the G. This is what that means. That's what that little circle means. So let's do it. Let's go N equals, and let's write the G function first. So this time we're going to write the purple first. We have -3 over 4 times something plus 3. And then, this is nice. We only have to plug it in once. Some functions have more than one spot to plug it in. This one doesn't. It just has one spot to plug it in. So I can put 2x plus 1. Do we get the same thing as what we got before, or do we get something different? That's kind of an interesting question. What is that times that? That would be -3 over 2, because the 2 would cancel out with the 4. That would be a 2. That would be a 1. And we have x, and then we get -3 over 4 plus the 3. Let's make that 3 have a common denominator, so we just have improper fractions. That would be 4 and 12 on top, right? 12 over 4 is the same as 3, right? Right. Okay, so then we have equals -3 over 2x. Then we have -15 over 4. Let's just leave it like this, shall we? We shall. All right, looks like I made a mistake. It's supposed to be -3 plus positive 12, so that would be 9, right? Yeah. This is -3 and 12, that's 9, so we get positive 9 over 4. Oh, there we go, that's better. All right, last one is this one right here, and I had to do this one just because it's weird, and sometimes weird things happen to you. You guys don't know what to do with yourselves. So this one, we're plugging G into itself. So I'll put parentheses around it. It would look like this, G with G inside of it. You're plugging G into itself. What? This is weird. Yeah, I know it's weird. Okay, let's do it. We have this is a P function, so P of X is going to equal, and the G is all purple, so we're going to go -3. How come I had to choose G? I had the fraction in it. And then we have plus 3. So that's the G function, and now we're going to plug the G function inside of it. What happens when we plug a G function inside of itself? Nothing magical. Don't get excited. That guy times that guy is going to be a positive 9 over 16. Then we're going to get a negative. Let's see, that'd be 2, 1, that'd be 2. Okay, so we get -3 over 2. Did I make a mistake?
No, just put it 2 instead of a 3.
I put a 2 instead of a 3. Oh, snap. That's supposed to be a 3 right there?
Yeah.
Oh, snappity whackity dackety backety, shoogity boogity boggity, jiggity biggity dee. What's he doing? Okay, so we got this times this. Oh, okay, now we got negative. That'd be 9 over 4. Can't simplify that, dude. Then we have the plus 3 chilling outside, but I'm going to make him have a denominator of 4, so the top would be 12. Don't forget your x, Mr. Patey. Come on. All right, so now we have 9 over 16x. And we have a negative 9 over 4 plus a positive 12 over 4, which would be 3 over 4. Is that it? Yep, that's it. All right, everything's right. PX. Shebang-a-dang. Now, the only other thing that you guys could see in the future is something like this. Yeah, I don't think I showed you this yet. Like if M, let's say you're plugging 2 into M. You guys see what M is over here? Then that would mean that you're going to plug 2 into the inner function first. Now, you can do this two ways. You can either, one, find out what M is first and then plug the 2 into it. Or you could plug 2 into the G function, get your answer, and then take that answer and plug it into the F function. So you plug 2 into here first, blah, 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 and then you plug it into this, blah, 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 and you get your answer. Does that make sense? Yes, no, maybe. Since I did the work to find M, I'm just going to plug 2 straight into what I got for M. And M is negative 3 over 2 times x plus 7, negative 3 over 2 times 2. And I'm going to add 7 to it. I get, that's going to be a negative 3 plus 7 is going to be a positive 4. And so if you took that 2 and plugged into this one first, and then plugged it into this one, you'll get a positive 4 in the end. For this one, we looked at combinations of functions algebraically. We can also look at it graphically. That's for the next one.